All right, so week one, our first section is section 1.1. Okay. So in section 1.1, we are talking about numbers, data, and problem solving. Okay. So what's important here is we're going to talk about recognizing common sets of numbers, evaluating expressions by applying the order of operations, learn scientific notation and use it in applications, and apply problem solving strategies. And then also calculating percent change. So just operations with numbers for the most part. Well, before you operate with numbers, you also need to know how to classify numbers, okay? We have what's called our real number system, okay? Our real number system is broken into two categories, rational numbers and irrational numbers. Your rational numbers are the numbers that you use pretty much on a day-to-day basis. Your rational number, the best way to think about it is we're going to start from the inside. Your natural numbers are the first thing you learn. Like you have one nose and two eyes and what do you have three of? I don't know what you have three of, but it's your natural numbers. 1, 2, 3, blah, blah, blah. Okay. What separates natural and whole is literally just the zero. Once you include zero, now you're talking about a whole number. Okay. Integers are now natural, whole, and their opposites. And then rational is everything else. So your repeating decimals, your terminated decimals, and your fractions, okay? Those are rational. Everything else is irrational. So the square root of 3, pi, your pattern repeating decimals, those are all irrational numbers. If I am a natural number, I'm a rational number, okay? If I'm inside, then everything on the outside applies to me. So breaking it down just a little more, your natural numbers or your counting numbers, again, we represent that mathematically with the letter N. Okay, sometimes you'll see it as a double-lined N. That means that I'm talking about natural numbers, okay? Whole numbers, your whole numbers again are the natural numbers and the number 0, and that's represented with the number, the letter W, it's not number, and typically when you write it, it's written with a double line to show that you're talking about a set of numbers. Integers, our integers are numbers in the set of I equals, but integers can either be represented with an I or with a double line Z. Is that how you make a Z? That's Z, right? Yeah. It felt weird. But that's with a Z. And lastly, our rational numbers are all of our numbers. So all numbers. Key thing is rational numbers can be expressed as decimals that either terminate or repeat a sequence. And that's just a breakdown of them. And again, don't feel the need to write all this down at this moment. You do have access to it. The last of the categories is irrational numbers, are numbers that are not rational numbers, right? They cannot be expressed as the ratio of two integers, so they cannot be written as a fraction, and they have decimal representation. However, the decimal does not terminate, which means n, and does not repeat. So for example, square root of 2, square root of 15, or pi, those are irrational numbers. Okay, so what you see circled are examples of real numbers. And that's because all of these can be written as terminating decimals or non-terminating, but pattern repeating decimals. All right, so we're going to practice classifying. We're going to classify whether it's a whole, integer, rational, or irrational. So 5 is 5, natural, whole, integer, rational, or irrational? 5 is all of this. 5 is natural, 5 is whole, 5 is an integer, and 5 is a rational. It would be everything except irrational. What about negative 1.2? It's rational, and that's it, right? What about 13/7? Good. What about negative square root of 7? Irrational. What about negative 12? It's rational and an integer. What about square root of 16? Is rational and it's an integer and it's a whole number and it's natural. Do you understand why? What is the square root of 16? 4. And it falls into all those categories, right? And then what about 0? A whole integer, which makes it rational. Okay, so that's classifying numbers. How do we feel about classifying numbers? Good? All right.